In this video, we are creating a fully parametric footing family with column and PCC layer, which is highly useful up to LOD 300 stage. Let's learn how to build this step by step. If you find this content helpful, please subscribe to the channel and support. Alright, let's begin. From the home screen, go to Families and click New. Then select Metric Structural Foundation. Now we'll start by creating reference planes. Go to the Create tab and select Reference Plane. Draw two vertical and two horizontal reference planes. Exact spacing is not important at this stage because these planes will act as the control framework for our footing dimensions. Next, go to Annotate and use Align Dimension. Dimension the three vertical planes and then the horizontal planes. Apply the equal constraint so the footing remains centered and expands equally from the center. In parametric family creation, reference planes act as the skeleton, and all geometry should be controlled through them. Okay, now convert the overall horizontal dimension into a parameter named length and the vertical dimension into width. Let me flex once. Looks perfect. Adjusting the view scale for better visibility. Now in elevation view, create two reference planes below reference level. Now add dimensions and assign the default parameter named footing thickness. And also create one new parameter as foundation depth and assign it to another dimension. For now, keep them as type parameters. Later we will change them if required. Foundation depth controls how deep the footing goes below reference level, and footing thickness controls the concrete thickness. Let's check our parameters again. Everything is working correctly. Now let's create the footing geometry. Go to Create and select Extrusion. Draw the footing shape as shown. Then use Align to lock all faces with the reference planes. Now repeat for all sides. Check once. Perfect. The footing is ready. Now we will create the column in the same family. Create new reference planes for the column. Add dimensions, apply equal constraint. And create two parameters, column width and column length. Check once. Yes, it's working fine. Now go to Create and select Extrusion. Draw the column shape, align and lock all sides. Now fix the height constraints. Align the column bottom with the footing top reference plane so it moves with depth changes. Create a new horizontal reference plane above reference level. Add a dimension. Create a parameter named reference level to ground level. Let me change the value to 150. And align and lock the column top to it. Let's flex once and check if everything is working properly. Now our column and footing are working together perfectly. Now let's create the PCC layer. In elevation view, create a reference plane below the footing bottom. Add a dimension and create a parameter named PCC. Keep default thickness as 75. Go back to reference level and draw reference planes as you see on screen. Now create an extrusion for PCC as shown. Align and lock all sides. In elevation, align and lock the PCC bottom to the new plane and the top to the footing bottom reference plane. Provide dimensions as you see and assign the PCC parameter to it. Let's check once. Oh, it's working perfect. Now let's assign subcategories to the column and PCC. Go to the Manage tab and open Object Styles. Under the Structural Foundation category, create new subcategories for column and PCC as shown on the screen. This allows us to control line weight, line color, material appearance, and visibility settings independently from the project's visibility graphics. By doing this, the column and PCC can be turned on or off separately in views, which makes the family more organized and project-friendly. From the Properties palette, assign the correct subcategory to each element. Now save the family as ISO footing with column. Once done, load the set into the project. Quickly checking if everything is fine. Now notice all parameters are type parameters. This means the size is controlled by the family type. If we change one footing, all similar footings will change together. We cannot adjust them separately at this stage. In real projects, footing sizes vary, so go back to family types and change all required parameters to instance. Follow the visuals and do as shown on the screen. I purposely used the type option earlier to cover the topic difference between type and instance parameters. After changing them to instance, each footing will behave independently. Now we can assign and modify parameters separately for every footing. Each element can have its own size as per design requirement. Once done, load the family back into the project and overwrite the existing version. Now each footing can be controlled individually from the Properties palette. Let me show an example. Now sizes can be changed separately. You can also create and add more parameters as per your requirement. Share with us your suggestions or any feedback. We are also available on Insta, LinkedIn, and Facebook. Finally, create material parameters and assign them to footing, column, and PCC as shown. Make sure you are in the correct views. You may slow the video for better visualization. Load again and check. Proper material assignment is important for quantity extraction. And in an upcoming video, we will cover MTO and SOQ in detail. That's it for this family. You can add more parameters based on project need. Thank you for watching. Please subscribe and share your feedback in the comments or through Instagram and LinkedIn.